good stuff. All right, gentlemen, here we go. All right. I'm going to show you how to calculate the theoretical yield, and then I'm going to explain to you why we're doing that. Okay. In my made-up results of I ended up with 0.3 grams of magnesium oxide, in order for me to compare what should have happened, we calculate how much should have been made. Hence the name theoretical yield. When you yield something, it's like something's being produced. Okay, so here we go. From here, in order for us to determine, Ruben, in order for us to determine the theoretical yield, we must, because we're determining how much stuff of the thing we made in the chemical reaction, this is where the balanced equation is required. Okay? So there's all the stuff, and here is the balanced version. And what we can see is for every 2 moles of magnesium, 2 moles of magnesium oxide should be produced. In other words, between magnesium and magnesium oxide, it's a 1-to-1 ratio. All right. So therefore, if from my calculated value of 0.0082 moles of magnesium, if I had 0.2 grams of it, so what we did was, if we said 0.2 grams of, so we want number of moles of magnesium, that divided by 24.31 grams per mole is equal to 0.0082 moles of Mg. Therefore, according to this stuff, I should have 0.0082 moles of MgO produced. That's the molar mass of magnesium. And because I'm calculating the moles of magnesium, I need to use its molar mass. All right, so, we're about to. So, yeah. So, hang on. All right, so let me say that again. We've just looked at how many moles of magnesium we had with our 0.2 grams, and now we know, because of the balanced equation, how many moles of magnesium oxide should be there. So that's not meaningful to us. That's not the theoretical yield. So we want to use n equals m over big M and rearrange it, because we want to know this, and we know this and this. 0.0082 times the molar mass of magnesium oxide, which is 24.31 plus 16. So,
from the mole. Is that time? No, that makes sense. Yeah, it does. Well, how do we know that?
Can someone do? I'll do this now. All right, 0.0082 times 40.31 is okay. So what does that mean? All right. So what I did was, hang on. What we did was we calculated how many grams of magnesium oxide I should have produced if everything went perfectly. I should have made this much. So I did that by balancing the equation, figuring out the mole ratio. Well, they're the same number, right? Because it's the same ratio. Yeah. So we calculate the number of moles of magnesium, which is equal to the number of moles of magnesium oxide we should have produced, and then I convert it into mass to find out how much I should have had in total. So this here is my theoretical yield. This is how much I should have made, theoretical yield. This is how much I should have made versus my actual yield, which I measured in my experiment, which was a made-up value of 0.3 grams. Okay? So now we have a value to compare it by. So we could do a percentage percentage accuracy, which is 0.3 divided by 0.33 from here and here. Oops, times by 100.
Why do you know? Is it always actually on top?
Yeah. Yeah. All right. So
So at the point of takeaway, you just add